All right, here's the first problem. 4,204 divided by 3. Let's draw our box model. Our box does not need to be very large because we only need the ones, the tens, the hundreds, and the thousands place, and enough room to write each of the numbers. And we're dividing this by 3. So now we're set up to go. I'm going to draw the base 10 blocks over here. 4,200, 0 tens, and 4 ones. Pause the video if you need more time to draw those. Alright, we are going to start in the largest place because we might have to break down and decompose in order to divide. So, we have 4 thousands. Can we divide 4,000 into 3 groups? Yes. We can have 1 group, 2 groups, 3 groups. The number that goes on top is how many are in each group. Well, in each group we have 1,000. So we're going to put a 1 in the thousands place. Let's check it. 1 times 3 is 3. We used 3 thousandths. How much do we have left? 4 minus 3 is 1. There is still 1,000 left. What do we have to do with that 1,000? We have to regroup it into hundreds. So 1,000 is 10 hundredths. So now we have 12 hundredths. There's 12 hundredths here and there's 12 hundredths here. Can we divide 12 into 3 groups? Now I like to skip count to do this. So I'm going to skip count by 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Okay, 12 is right here. It is a multiple of 3. So that would be 1, 2, 3, 4 in each group. So we're going to put 4 in each group. So I'm going to circle 4. There's 4. There's 4. And there's 4. We can see that there's 4 hundredths in each group. 4 times 3 is 12. We used all of our 12 hundredths, so we have none to regroup. Okay, here is where it might be a little confusing. We now have 0 tens. There's no tens. Can we divide 0 into 3 groups? No. So there's not going to be any in each group. So we're going to put a 0 in the tens place because we're not making any groups. 0 times 3 is 0. We had none. We made no groups. There's still no tens. So we're not going to regroup anything into the ones place. There were already 4 ones in the ones place. So we have to say, can we put these into 3 groups? Yeah, we can. 1, 2, 3. There is 1 in each group. So 1 times 3, if we're checking it, 1 times 3 is 3. We subtract because we already used these 3. That gives us 1 left over. When we have something left over, like this one, we call it the remainder. So our answer would be 1,401 remainder 1. So that means that in each of these 3 groups, there is 1,401, which is why when we check it, we say 1,401 times 3. You do not add your remainder here. You add your remainder after you have your answer. You must make an area model to check this. So we have our 4 places, because there are 4 places in this number. And we're multiplying it all times 3. So once you multiply all of this, then you need to add. Once you add it, then you add your remainder to the answer. So you get an answer, and you have to say, oh, I had a remainder, plus my remainder of 1. All right, go ahead and do that, and insert a picture on the slide. Then you will come back and continue with the next video. The next problem is 2,789 divided by 5. Let's draw our box method. We don't need a very big box, just big enough to write the numbers in. And we need 4 places: the ones, the tens, the hundreds, and the thousands. So we have 2,789 divided by 5. All right, go ahead and write that, and then draw your base 10 blocks over here. Pause the video if you need more time to do that. We're going to start with 2,000. Can we divide 2,000 into 5 groups? Not when they're in thousands cubes. So we need to say, no, that's not going to work. We can't divide groups of 1,000 into 5 groups. So now we will say, all right, that didn't work. I used 0 thousands. 0 times 5 is 0. Now we have 2 thousands remaining. We have to regroup those 2 thousands into hundreds. So we're going to take our 2 thousands here, and we're going to regroup them into 20 hundreds. So here we have 10 hundreds, and here we have 10 hundreds plus the 7 that we already had. Now we have 27 hundreds. Can we divide 27 into 5 groups? Sure we can. And it's really easy. We know how to count by 5s. You could probably count by 5s on your fingers just as efficiently. But for the video's purpose, I wrote them out. Where does 27 fall on this skip counting of 5? It falls between 25 and 30. So the largest groups of 5, if we use groups of 5, we can use 1, 2, 3, 4, 5 in each group. So we will use 5 hundreds in each group of 5. There's 1 group, 2 groups, 3 groups, 4 groups, 5 groups. There's 1, 2, 3, 4, 5 groups. So we used 5 times 5 is 25. How many hundreds are left? There's 2 hundreds left. They are here. 1, 2. We need to regroup these into tens, and we will regroup both of our hundreds pieces into 10 tens each. So now we have 10, 28, 28 tens. Let's look at our skip counting. Where would 28 fall on this line? Right here between 25 and 30. So how many tens will be in each of the 5 groups? Well, 1, 2, 3, 4, 5. tens will be in each of the 5 groups. 5 times 5 is 25. If we use 25, there should be 3 left. Let's show that with our base 10 blocks. So we need 5 in each group. 1 group, 2 groups, 3 groups of 5, 4 groups of 5, 5 groups of 5, and there are 3 remaining. We're going to regroup these into ones. 3 tens is 30 ones. And we can see that when we regroup 3 tens into 30 ones, we now will have 39 ones. So there's 10 ones, 20 ones, 30 ones, plus the 9 we already had is 39 ones. Where does 39 fall on our skip counting? It's between 35 and 40. So let's see, how many will be in each of the 5 groups? 1, 2, 3, 4, 5, 6, 7. 7 will be in each of the 5 groups. 7 ones. Let's circle 7 ones. There's 7 ones. 7 ones. 7 ones. 7 ones. 7 ones. All right, there we have 1, 2, 3, 4, 5 groups of 7. 5 times 7 is 35. If we subtract that, we have 4 left over. And here we can see our 4 left over. These are our remainder of 4. Now it's your turn. Go ahead and take our answer, 557, remainder 4, and multiply it. You must do an area model. So draw your area model with your ones, tens, and hundreds. 500 plus 50 plus 7 times 4. Once you have each of your answers here, you're going to add them up over here on the side and see what you get as your answer. If you do not get 2,789, perhaps you still need to add your remainder. If you have any problems with that, go ahead and ask me. Pause the video so that you can finish your checking with multiplication. On the following slides, you will solve a few problems independently. Make sure you insert a picture of each of your work pages into the slides. Great job!